Good evening, dear students. In the series of amines, we have uploaded 12 lecture in our channel Chemistry Guru 1993. Chemical properties of amines is almost finished. Lecture number 13. In this lecture, we will finish all the chemical property of amines. Okay. So in that case, lecture number 13 we are going to start. So chemical property of amines till the reaction with aryl sulfonyl chloride in the last video we covered. Next chemical property is electrophilic. Electrophilic substitution. Electrophilic substitution reaction. So check it. In the case of electrophilic substitution, what kind of product we are getting, ortho, meta or para. So here this is our aniline, alternate double bond. Here NH2 is present with lone pair. So NH2 is showing plus R or plus M effect. Plus R or plus M effect. That means it is throwing electron towards the ring. Then resonance is possible. Here ortho position, this one is also position, this is para position, this is meta position, this is also meta position. Okay, this is also meta position. So because of the resonance, these electron will shifted here, these electrons shifted here, these electrons shifted here. So according to that, ortho and para directive compounds are possible. Ortho and para directive compounds will be formed. Okay, so how ortho and para directive compound will be formed? First chemical reaction, bromination. In the case of bromination, children, here we are having amine NH2 reacting with bromine water. So what electrophile is? Electrophile is Br positive. It is your electrophile. So all the ortho and para position occupied by bromine. Here bromine will be attached. Here also bromine attached, and here also bromine attached. And here HBr comes out. So 3 molecule and 3 HBr. So this is the chemical reaction in this case. So the problem is we are getting all the ortho position and para position bromine is attached. Monodirective compound we are not getting. Why? Due to high reactivity of NH2 group. This is happening because of high reactivity of NH2 group. If we want to form monodirective compound in that case of bromination, then we have to perform acetylation. Okay, we have to perform acetylation with anhydride, acid anhydride. So children, the concept is, here I am writing, try to understand what I want to explain you people. This is your amine. In that case, this lone pair, because of the lone pair, this aniline is very reactive. All the ortho and para position occupied. These electron flow towards the ring. But if anyhow we are able to busy these electron, these lone pair electron, if we are able to visit somewhere else except resonance, then monodirective compound will be formed. So in the case of acetylation, we are trying to do this work. We are going to busy the electron. So check it here. This is our aniline and lone pair, acid anhydride CH3CO C double bond O. In the presence of pyridine, if you are doing this, then what happened? Here you are having two positive center, this carbon and this carbon, any one you can choose. Then lone pair attach with the positive center, and you will get hydrogen C double bond O and CH3. This species you will get. Okay, I am writing clearly here, it is not clear. So we will get nitrogen C double bond O CH3 and one hydrogen. And one hydrogen with this species will form CH3 COH. So still this nitrogen is having lone pair, but this time lone pair are busy in this side. They will shift here and oxygen electron will shift on the oxygen pi electron. So one more resonating structure you can draw. So lone pair electron are busy this side. So by the acetylation you can form monodirective compound. So check the bromination once again. In that case, again we are having this aniline, acid anhydride CH3 CO whole twice NO. In the presence of pyridine, what happened children? Same, just like previous. Nitrogen C double bond O CH3 and one hydrogen, and byproduct CH3COOH. Still this nitrogen is having lone pair, but now this time they are busy in resonance outside. Then again you are using bromine water. This time the product will be, bromine will be here nitrogen, hydrogen, C double bond O, CH3. Tell me children, ortho compound will be formed or para compound will be formed? So here children, para directive compound will be formed, not ortho. Why not ortho? Because here it's a steric hindrance. Steric hindrance. Because of steric hindrance, attachment on the ortho position is not possible, and para is symmetrical also. So that is why para product is formed. In the next step, if you are doing acidic or basic protonation, then what happened? Your monodirective compound para bromoaniline will be formed. Para bromoaniline formed. If direct bromination if you are doing, then what you will get? Again I am explaining here. All the ortho and para position will be occupied. For that we prefer acetylation. White PPT. Okay. So that is all about the bromination. Come to the nitration. That reaction is very important. Nitration, and this is important also. Why important? You will understand. Here we are having aniline. How nitronium ion generated? HNO3 H2SO4. Here I am telling you how it will be generated. See, wait. Here, how the ion will be generated? H2SO4. So for H2SO4, we are writing HSO3HOH plus HO and NO2. This is sulfuric acid, this is HNO3. Here this oxygen is having lone pair, this is acidic hydrogen, it will be attached here. Then what you will get from here, OSO3H, O minus, that species is free, and you are getting oxygen with positive sign, two hydrogens attached, and NO2. Then positive charge will be banished by dropping H2O. From here water will be released and that nitronium ion will be generated. Once again I am telling you, here sulfuric acid, here sulfuric acid HNO3, then this is acidic hydrogen approach the lone pair, then positive charge on the oxygen, then these electrons shifted, water removed, and NO2 will be generated. Okay, so but this is not a special thing. The thing is, what is the important part? Here we are getting NH2 and here NO2. 51% 51% para product and NH2, 2% ortho product is formed. So tell me children, where is other 47%? So that is the interesting part of this reaction. Check it. Here what happened children? Acidic medium is there. So H plus is present. And here you are having lone pair. So lone pair approaches by H plus. And here anilinium ion generated. What it is? Anilinium ion. And anilinium ion will show minus R or minus M effect. That means meta-directive compound. That is the special part of the reaction. Meta-directive compound, just like carboxylic acid. And the meta-directive compound, which is more than ortho also. 47% meta-directive compound will be formed in the case of nitration. So that is the interesting part of this reaction. Similarly, again, if you want to form a monodirective compound, then what happen in that case? Again, same thing you have to do. What is the thing that you have to do? Acetylation. I am writing the simple reaction. Here we have to take aniline, NH2, lone pair, CH3, C double bond O, CH3 in the presence of pyridine. What happened? Same NH, C double bond O, CH3 generated, then HNO3, H2SO4, NO2 plus electrophile generated. Then what happened? Same para product is possible. NH C double bond O CH3 NO2 ortho because of steric hindrance not possible. Then acidic or basic protonation if you are doing, then monodirective compound is possible. This is your NO2. So that's all about the nitration. So thank you. One more video we will discuss in sulfonation only, around 5 to 6 minutes it will take. In the next video, we will complete the sulfonation process, and that amine will be finished. After that, we will finish the in one lecture diazonium salt. Next chapter will be biomolecule. So please share the video and like it. Thank you.